Astronauts aboard China's Tiangong space station have for the first time produced oxygen and ingredients for rocket fuel in orbit using artificial photosynthesis technology, in a breakthrough that could support long-term human presence beyond Earth. Pause for a few seconds and support me with a subscribe. In January 2025, the Shenzhou 19 crew carried out 12 experiments in a drawer-sized device, using semiconductor catalysts to convert carbon dioxide and water into oxygen and hydrocarbons. State media and the China Manned Space Agency said. The results mark the first in-orbit demonstration of the process, which mimics plant photosynthesis, but functions at room temperature and normal pressure, reducing energy consumption compared with conventional systems, reports NDTV. Researchers successfully generated ethylene, a hydrocarbon that can be used as rocket fuel, paving the way for sustained crewed missions, including China's goal of landing astronauts on the moon before 2030. The South China Morning Post reported. The experiments also examined gas transport and separation in microgravity and real-time detection of reaction products. Adjusting catalysts could enable the system to produce other fuels, such as methane, CMS said. Artificial photosynthesis uses engineered physical and chemical methods to replicate how plants process carbon dioxide, producing oxygen and fuels in confined or extraterrestrial environments, state broadcaster CCTV said. Current life support systems, such as those aboard the International Space Station, rely on splitting water with electricity from solar panels. While effective, this consumes nearly a third of the station's energy, according to a 2023 study led by Katharina Brinkert of the University of Bremen. By contrast, China's technology could make long-duration space missions more viable by cutting energy costs and creating locally sourced propellant. Let's pause for a few seconds and give me a like for this video. Thank you so much. Magnets could make bulky centrifuges obsolete in space oxygen systems. Scientists have developed a more efficient way to generate oxygen for astronauts that could help with future missions into deep space. Current life support systems, such as those on the International Space Station, ISS, rely on bulky centrifuges to separate the oxygen and hydrogen bubbles created when water is split by electricity, a process known as electrolysis. On Earth, bubbles rise away from electrodes, but in microgravity, spinning is required to separate them. This method works, but the equipment is heavy, power-hungry, and is ill-suited for long-duration missions to the Moon or Mars. A new study led by Álvaro Romero Calvo of the Georgia Institute of Technology, in collaboration with colleagues at the University of Bremen's Center of Applied Space Technology and Microgravity, ZARM, and the University of Warwick, has demonstrated a simpler, lighter, and more sustainable solution in the form of magnets. The team has shown that magnetic forces can guide gas bubbles in microgravity to collection spots, eliminating the need for mechanical spinning from heavy centrifuges. Their findings were published this month in the journal Nature Chemistry. In this paper, we demonstrate that two largely unexplored magnetic interactions, diamagnetism and magnetohydrodynamics, provide an exciting pathway to solve this problem and develop alternative oxygen production architectures, Romero Calvo said in a statement. Using ZARM's 479-foot-tall drop tower in Bremen, Germany, the team tested the technology, producing an increase in bubble detachment efficiency of up to 240%, which would translate to much more effective electrolysis cells and oxygen generation. After 4 years of hard work, showing that magnetic forces can control electrochemical bubbly flows in microgravity, is an exciting step towards more efficient and reliable spacecraft life support systems, Romero Calvo said. The approach was first developed by Romero Calvo as part of his doctoral thesis, and then proven feasible through a grant from the NASA Innovative Advanced Concepts Program. The team is now set to continue the research under NISC and European Space Agency programs. to assess the implementation, scalability, and long-term efficiency of different water-splitting architectures. Relying on magnetism using both the microgravity drop tower and suborbital rocket experiments. The German Aerospace Center also supported the research. Elon Musk and Jeff Bezos are trying to figure out how to pump gas in space. The billionaire space rivals are working on ambitious missions to the Moon or Mars. And a crucial design element for each venture is using spacecraft that take on additional fuel while orbiting Earth. Vehicles that could grab propellants in orbit would be less weighted down at liftoff, letting planners design missions to travel farther from Earth with more cargo, scientific gear, or crew members, advocates say. Having depots or in-orbit refueling that gives spacecraft something like a truck stop to pull into may sound like science fiction. It is also a concept that engineers have been working on for years. One of the biggest challenges to making it a reality: moving and storing massive amounts of supercold propellants that are prone to boil off in the void of space. Both SpaceX and Blue Origin have much to prove. Some space industry officials are skeptical that either will have moon landers. That depend on orbital fueling ready to meet National Aeronautics and Space Administration timelines. The agency has worked closely with contractors to understand the challenges of in-space refueling, a NASA spokesman says. SpaceX conducted a fuel transfer demonstration inside a Starship spacecraft during a 2024 test flight, and next year is aiming to move propellants between two vehicles. That test has been delayed as the company has faced setbacks with the massive rocket, including an explosion during a ground test in Texas in June. Blue Origin is developing a transporter vehicle that would take on propellant near Earth. Then, it would fly to a lunar orbit, where the transporter would prepare a lander. That would take astronauts arriving on a different ship down to the surface of the Moon. That mission depends on the company's New Glenn rocket, which the company launched for the first time in January. Engineers have long built rockets and spacecraft to take on all the fuel they need while still on the ground. Those designs have proven their value. They also have their limitations. Take NASA's Apollo missions to the Moon. Saturn V, the rocket that sent agency astronauts there, weighed 6.5 million pounds at liftoff, and around 5.5 million of those pounds were fuel. Combined with reusable rockets, fueling in space could make deep space flights cheaper over time and ease mission logistics, supporters say. It has got to be done, says Dallas Bienhoff, who formerly studied setting up a low Earth orbit propellant depot for Boeing, and now works for Pasadena, Calif-based robotic mining company Offworld. Otherwise, we're going to be limited with what we can achieve in space. Musk put it this way during a conference talk in 2017. Starship, which then went by a different name, was expected to loft a spacecraft carrying a large amount of mass to low Earth orbit. The ship wouldn't be able to travel farther without more fuel, he said. If you send up tankers and refill in orbit, you can refill the tanks all the way to the top, Musk said then. That would allow the ship to continue out to Mars, he added. From Apollo to the present, orbital refueling isn't a new idea. In the early 1960s, NASA officials considered such operations as they tried to figure out how to land astronauts on the lunar surface before the Soviets. The idea didn't go forward then, but it didn't go away. A range of in-space fueling experiments or operations have been conducted over the years, including by Russia. In 2007, the Pentagon's Defense Advanced Research Projects Agency and partners conducted more than a dozen fuel transfers between two satellites. But no U.S. company has put in-space propellant transfers at the center of their deep space plans as SpaceX and Blue Origin have. Part of the reason is making it all work is difficult. Spacecraft will need to rendezvous in orbit, connect with each other, and flow large amounts of propellants from one vehicle to another. For many planned Starship missions, SpaceX will need to fuel up spacecraft as the vehicles speed around Earth. Starship is the huge rocket SpaceX is developing. The NASA lunar mission would start with SpaceX, launching a depot version of Starship to low Earth orbit capable of storing propellants, agency officials have said. After the depot is in space, SpaceX would fill it up by launching tanker ships loaded with fuel. Those tanker vehicles would need to catch up with the depot, dock with it, and transfer in propellants hauled up from the ground. It isn't clear how many launches would be needed. Conducting fuel fill-ups in space is expected to be a challenging operation. The propellants need to be stored and moved while at super cold temperatures. They are tricky to manage and prone to boiling off. When the depot is fueled, a lander Starship would launch to fill up there. Then, it would fly to a lunar orbit and pick up astronauts from NASA's Orion craft. The lander would take them down to the moon and back up to Orion. The Orion vehicle would return the crew to Earth. The nature of the propellants SpaceX and Blue Origin have proposed using makes transferring them especially tricky. The fuels are chilled to super cold levels to keep them liquid and have a tendency to boil off. It wouldn't be easy to do on Earth, but now you have to do it in space. Pumping it from one big refrigerator to another, says Thomas Cooley, formerly chief scientist for a space vehicles group at the Air Force Research Laboratory, who now has a space consulting business. Dave Limp, chief executive at Blue Origin, said in a social media post in July. The company had made major progress maturing technologies that aim to prevent propellants from boiling off in space. Fuels also behave in odd ways in space. When you pump gasoline into your car's tank, the gas flows in a predictable manner. But that isn't necessarily the case in orbit. There, companies will contend with what William Notardinato, chief executive of Ada Space, calls liquid acquisition issues. You don't know where your liquid is stored. The propellant might be up at the top of the tank. And it brings up the question, what is the top in microgravity? Says Notardinato, whose Rockledge Flom-based company is developing an in-space propellant depot and working on a mission where it will track how a supercold propellant behaves in a satellite tank using a camera. Another unknown for in-orbit refueling, the number of launches it will take SpaceX and Blue Origin to fuel up vehicles for deep space missions. SpaceX has shown launches can be conducted much more frequently than in the past. But rockets are still a long way from flying as easily as commercial jets. Meanwhile, Starship, the company's vehicle that will use orbital fueling, remains in an experimental phase. And Blue Origin is still ramping up New Glenn. During a presentation earlier this year, a Blue Origin executive didn't specify how many refueling flights the company may need for a NASA mission that has it transporting astronauts from lunar orbit to the surface of the moon. For its NASA astronaut moon missions, SpaceX has been planning to conduct multiple launches of a tanker variant of its Starship spacecraft to fuel up a Starship depot in low Earth orbit, according to NASA officials. Then the company would send a moonlander Starship to the depot to take on fuel. After that, the lander would fly out to the moon. An executive at SpaceX early last year estimated a moon mission for NASA could take around 10 flights, while a different leader at the company last fall predicted around 16. Some current and former space industry officials say the number of launches needed may be higher. One former NASA leader during the congressional hearing in February said as many as 20 could be required. A technical paper that has circulated among some industry officials and was viewed by the Wall Street Journal suggests it may take up to 40. Musk, during a recent presentation about SpaceX's plans for Mars, didn't discuss the number of flights that would be needed to send a Starship to the Red Planet. Staff at the company have talked about trying to send a basic uncrewed ship out there next year, with as few as 3 refueling flights, the Journal has reported. In a recent post on his social media site, X, Musk said a Starship flight to Mars in 2026 would be tough, giving it just a slight chance of happening.